the order of integers, what's larger, what's smaller, and add, subtract, multiply, and divide. So let's look at the first examples in your notes. It has a number line there, and we want to put in a less than or greater than. So looking at the number line, 6 is less than 10. Now again, where the point of this is the smaller of the two. So you can read this as 6 is less than 10, or you can read it 10 is greater than 6. Well, looking at the number line, which one of these is the largest, or which one's to the furthest right? And a minus 2 is greater than a minus 7. To understand that, you kind of need to think of a number line, not what the numbers look like. Now, another way of thinking about this is a minus number is a debt, a hot check, okay? And you'd rather be $2 in the hole rather than $7 in the hole. So this is a better deal. This is a larger number in terms of this number, in terms of the number line, okay? Okay, keep that idea about money in mind, and I'll show you how it works in a minute. All right, up here, the next one is 0 is greater than a minus 1. 7 is greater than a minus 2. Now, see, you do not have to read from left to right. You can read from either direction. And in my opinion, it's best to read it as what is the largest? Greater than. Largest, greater than. Over here now. 2, positive 2 is greater than a negative number. All right, next example. Well, how do I make that decision? Well, you can change this to an improper fraction, so that's 3/2, and then this would be 11/7. Wait a minute, that didn't tell us for sure. So what we could do is get these to be the same denominator. If I multiply the top and bottom by 7, then that would be 21/14. And if I multiply the top and bottom by 2, that would be 22/14. And now I have the same denominator. I can tell that this one is larger than that one. All right. Now, let's look at these 4 numbers. Which one of those is the largest, or which one's the smallest, whatever way we want to ask. Well, we've got to get the same denominator. So the common denominator here is 45. So multiply that by 15, that would be 15 over 45. Multiply this by 5, that would be 25 over 45. Multiply this by, 45 wouldn't work, would it? We need to make that 90s, okay? So let's come back and make this 30 over 90, and make this 50 over 90, and make this, 45 over 90, and then 6 times that would be 42 over 90. So now when we have it over the same denominator, we can tell which one's larger. Okay, so now let's look at absolute value. And again, listen to what absolute value says. Absolute value of a number says simply throw away the minus sign. So the absolute value of 4 is 4. The absolute value of a minus 4 is 4. Just throw away the minus sign. Now the definition says that if the answer in here is a positive, then the answer is that. If the answer is in here negative, make it a negative that. Well, that's a lot of talk. Simply say throw away the minus sign. Okay. Now over here to this one. 3 minus 5 is a minus 2. Throw away the minus sign. Okay. So that's the definition of absolute values of integers. Okay. It's a more complicated thing than that when you deal with algebra letters and stuff. But right now, just throw away the minus sign. All right. Now let's get to add, subtract, multiply, and divide. So I wanted to look at all 4 of these combinations. What this is saying is a plus number and a plus number, plus number and a minus number, a minus plus both minuses. Okay? And what I have down here below them is a way of writing it across this way. This says 4, now we're doing addition, 4 added to that, 4 added to a minus 2, minus 4 added to 2, a minus 4 added to a minus 2. So we're doing addition. All right, so plus 4 and a plus 2, plus 6. Plus 4 and a minus 2, plus 2. Minus 4 and a plus 2, minus 2. A minus 4 and a minus 2, minus 6. There's the answers, but I want to teach you a way of doing this. First of all, let's look at it as money. You deposit $4 and $2, you have $6 in the bank. You deposit $4 and write a $2 check, you only have $2 left. You deposit $2 and you write a $4 check, minus $2, plus a minus $30 for writing a hot check. And if you write a hot check and write a hot check, it's still minus 6. Okay? So think of it that way. Now, here's the way the math teacher is going to tell you. When adding, the signs are the same. Add the numbers and use that sign. When adding, the signs are the same. Add the numbers. Use that sign. All right. When the signs are different, subtract the number and use the sign of the largest one. Subtract the numbers, so subtracting, that's 2, and the sign of the largest. Subtract the numbers, sign of the largest. That's a mechanical way of working it. I'm going to say it all again, and then you pick out the way you like and you learn to use your method. When adding, and the sign's the same, add the numbers, use the sign. When adding, sign's the same, add the numbers, use the sign. When adding, and the signs are different, subtract the numbers, use the sign of the largest one. And without practice, to me, it sounds confusing. But with practice, you'll get it down. All right, down here it says, what is 4 added to 2? That's plus 6. What is 4 and you take away 2? That's 2. What's 2 and you take away 4? That's a minus 2. If you want to take a number line and think this way, okay? Let's do it this way. All right, so 4, we're going to come over 4, and then we're going to come over 2 more, so we're now at 6. Here we're at 4, and we're going to go back 2, so we're at 2. Here we're at a minus 4, and we want to come 2 this way, so we're still at a minus 2. And over here we're minus 4 and minus 2, which is a minus 6. So whatever helps you to understand that, get those patterns down. This is going to be so confusing if this is brand new to you when we go to subtraction and multiplication, division. So it takes a lot of practice, and so that's why I keep repeating, and I'm going to repeat it one more time. When adding, the signs are the same. Add the numbers. Use that sign. Signs are the same. Add the numbers. Use that sign. Signs are different. Subtract the numbers and use the sign of the largest one. All right. Now we're going to do subtraction on the same numbers. Okay? So I'm just going to leave the same numbers up here now, and we're now going to subtract them. All right, listen to the rule. Now, we spent 5 minutes talking about how to add. To subtract, all you do is go change the sign of the bottom one and add. Change the sign of the bottom one and add. So, adding here, signs are different. Subtract, use the sign of the largest ones. Adding, 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 Now this is the way it's going to look written sometimes. This is going to be 4 minus a 2. This is going to be 4 minus a minus 2. This is going to be a minus 4 minus 2. And this is going to be a minus 4 minus a minus 2. Now look what happens. 4 minus 2 is 2. 4 minus a minus is a plus. Okay. Minus 4 minus 2 minus 6. Minus 4 plus 2. Change the sign at the bottom and add. All right. All right. So, to me, work hard on your addition, and now when do subtraction is just to say change the sign of the bottom one or change the sign of this one over here and add. Change the sign of that and add. Change the sign of that and add. Okay. All right. Now let's go to multiplication. So now we're going to take these and multiply. Okay. So we're going to multiply, 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 multiply. Okay, so multiplication, 2 times 4 is 8, 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 no problem. A plus times a minus is a minus. A plus times a minus is a minus. A minus times a minus is a plus. So that's what you have to memorize. Minus times a minus is a plus. A minus times a plus is a minus. And I'm going to give you a thing to use in a lot of other places too. And this is this. When you're multiplying and you have an odd number of minuses, if you have 1 or 3 or 5 or 7 minuses, the answer is minus. If you have an even number of minuses, if you have 2 minuses or 4 minuses or 6 minuses, the answer is a plus. All right, division, same rule about the plus and minuses. Division, same rule about the plus and the minuses. Okay. So 4 divided by 2 is 2. 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 If you have 1 minus, the answer is minus. 1 minus. If you have an even number of minuses, the answer is positive. All right. That's the concepts seem very simple, probably, but they're very important that you memorize that in your brain. How to add, subtract, multiply, and divide plus and minus numbers. Okay. All right, I'm going to go over it one more time. When adding, you do what? Signs are the same, add. Use that sign. Signs are different, subtract. Use the sign of the largest one. Or think of money when you're adding. A plus 4 and a plus 2, $6 in the bank. $6 in the bank, write a $2 check, $2 in the bank, plus 2. $2 in the bank, write a $4 check, $2 in the hole. $2 check, $4 check, $6 in the hole. Just now go work all the sample problems on these note pages. Get this practice down. It takes practice, but you can do it.
product is negative 200 here. Let's try a few more examples. What about good old 8 times 2, just multiplying a few positive numbers together? You've never really probably given this much thought, but remember, you're multiplying a positive number times a positive number. The signs are the same, so the product will be positive also. 8 times 2 is, of course, 16. What about a positive 3 times a negative 5? 3 times 5 is 15. Opposite signs, so the product is negative. All right, let's multiply 3 numbers together, and let's see how you do. What about 2 times negative 3 times positive 4? You may want to work this in increments of 2. Let's take the first 2. 2 times 3 is 6, and then I have a negative times a positive, so the product is negative. And now this problem reduces to negative 6 times 4. Then 6 times 4 is 24. A negative times a positive, opposite signs, the product will be negative. And so your product here is negative 24. One more example before we talk maybe a little bit about exponents. Remember, 0 times any whole number was 0. Well, that's still true of the integers. 0 times any integer is 0 also. And this is also a good time to remind you that the commutative and associative and other properties of whole numbers apply to integers also. Now let's talk just a minute about exponent. This tape segment will review operations on numbers. Let's begin by looking at the addition of signed numbers. For addition, if you have like signs, add the absolute values and keep the sign. Once again, if you're adding 2 numbers with like signs, add the absolute values and keep the sign. If you're adding 2 numbers with unlike signs, subtract the smaller absolute value from the larger absolute value and keep the sign of the number of larger absolute value. One more time, if you're adding 2 numbers with unlike signs, subtract the smaller absolute value from the larger absolute value and keep the sign of the number of larger absolute value. Let's look at some examples. First, I have negative 16 plus negative 5. So I'm adding 2 numbers with like signs. When adding 2 numbers with like signs, add their absolute values. Well, the absolute value of negative 16 is 16, and the absolute value of negative 5 is 5. 16 and 5, that's 21. So I've added the absolute values and keep the sign of the 2 numbers. That would be negative. So my answer is negative 21. This is an example of adding 2 numbers with like signs. All right, let's look at another example. Next, I'd like to look at negative 9 plus 4. I'm adding again, but now I'm adding 2 numbers with unlike signs. All right, when adding 2 numbers with unlike signs, because remember this 4 is a positive 4, you take the absolute values again. That would be 9 and 4. Subtract the smaller absolute value from the larger absolute value. Well, 4 from 9 is 5. And then you keep the sign of the number of larger absolute value. Well, the sign of the 9 is negative, so my answer is negative 5. Let's go over this one more time. Negative 9 plus 4, I'm adding 2 numbers with unlike signs. So you say 9 minus 4, which is 5, and then keep the sign of the number with the larger absolute value. That would be negative. My answer is negative 5. Let's look at another example. What about positive 5 plus negative 5? Positive 5 plus negative 5, you're adding two numbers again with unlike signs. Well, take the absolute values of these two numbers, 5 and 5, subtract them. 5 minus 5 is 0, and I say keep the sign of the number with the larger absolute value. Well, the absolute values are the same. This is just 0 then. Again, I'm adding two numbers with unlike signs. By the way, these two numbers are called opposites of each other. All right, let's look at another example. What about 2 plus a negative 3? 2 plus a negative 3. I'm adding again two numbers with unlike signs. So think of the absolute values, which would be 2 and 3. 3 minus 2 is 1, and then you keep the sign of the number with the larger absolute value. That sign is negative, so my answer is negative 1. One more example, and then we'll go to subtraction. Let's simplify negative 10 plus negative 7 plus 3. Negative 10 plus negative 7 plus 3, I'll begin by combining the first two signed numbers, and then I'll worry about the third number in just a minute. So let's concentrate on the first two. Looking at the first two, you're adding two numbers with like signs, so add their absolute values. 10 and 7, that's 17. Keep the sign, so my answer there is negative 17, and then I have plus 3. Now I'm adding two numbers with unlike signs. All right, subtract their absolute values. 17 minus 3, that's 14, and keep the sign of the number with the larger absolute value. Well, that would be negative, so my answer is negative 14. Let's now move on to subtraction. Subtracting is the same as adding the opposite. One more time, subtracting is the same as adding the opposite. Let's look at some examples and go over this. Here I have negative 20 minus a negative 46. Negative 20 minus a negative 46, so I'm subtracting. Subtracting is the same as adding the opposite. Okay, I've rewritten my negative 20. It's the same as adding the opposite. Well, what's the opposite of negative 46? The opposite of negative 46 would be positive 46, or just 46 if you like it. And now I've turned this subtraction problem into an addition problem, and we can use those rules for adding then. Right now I'm adding two numbers with unlike signs, so subtract their absolute values. 46 minus 20, that would be 26, and keep the sign of the number with the larger absolute value. The sign would be positive, so my answer is positive 26, or just 26. All right, let's look at another example. What about 15 minus a positive 7? 15 minus a positive 7. Subtracting is the same as adding the opposite. So the opposite of a positive 7 would be a negative 7. And now we can use our rules for addition. I'm adding two numbers with unlike signs. Subtract the smaller absolute value from the larger absolute value. Well, 7 from 15 would be 8. Keep the sign of the number with the larger absolute value. The sign of 15 is plus, so this is a plus or a positive 8. All right, so my answer is positive 8 or 8. Let's look at another example. What about 7 minus 10? For 7 minus 10, subtracting is the same as adding the opposite. Well, what's the opposite of positive 10? The opposite of positive 10 would be negative 10. So this problem is the same then as 7 plus negative 10. All right, I'm adding two numbers with unlike signs. Subtract their absolute values. 10 minus 7 is 3. Keep the sign of the number with the larger absolute value. That would be negative, so my answer is negative 3. Let's try another example. What about 19 minus a negative 12? 19 minus a negative 12. Well, subtracting is the same as adding. The opposite of negative 12, and the opposite of negative 12 would be 12 or positive 12. Then I'm adding two numbers with like signs. You simply add their absolute values. That would be 31, and keep the sign, which is positive, so my answer is positive 31 or just 31. Let's try one more example. What about negative 9 plus 6 minus a negative 3? Negative 9 plus 6 minus a negative 3. Let me begin by working on the first two numbers. This is addition, and I'm adding two numbers with unlike signs. So subtract the smaller absolute value from the larger absolute value. 6 from 9 is 3. Keep the sign of the number with the larger absolute value, negative. So my answer so far is negative 3. And then I have minus a negative 3. Now the operation is subtraction. Remember, subtraction is the same as adding the opposite, and the opposite of negative 3 would be positive 3 or 3. Now I'm adding two numbers with unlike signs. Subtract their absolute values. 3 from 3 would be 0, so my answer here is 0. All right, that's a review of addition and subtraction of signed numbers. Let's now look at multiplication and division. First, let's review sign rules for multiplication. If you have a negative number times a negative number, your answer will be positive. A positive number times a positive number, that's positive. A negative number times a positive number is negative. And a positive number times a negative number is a negative product. So there's a rule or a review of your sign rules for multiplication. Let's now review the sign rules for division. A negative number divided by a negative number is a positive number. Positive divided by positive, that will give you a positive quotient. A negative number divided by a positive number is a negative quotient. And a positive divided by a negative will be a negative quotient. All right, that's a review of signs. Now let's look at some examples. First, I'd like to multiply negative 2 times 6. Well, 2 times 6, that's 12. And then remember, a negative number times a positive number will give you a product of a negative number. My answer then is negative 12. Let's look at a division. What about negative 9 divided by negative 3? Well, 9 divided by 3 is 3, and a negative divided by a negative will give you a quotient that's positive, so my answer is positive 3 or 3. All right, what about this example? What about negative 5 times negative 12? 5 times 12, that's 60, and a negative times a negative is a positive, so my product is positive 60 or 60. What about negative 35 divided by 5? Well, 35 divided by 5 is 7, and a negative divided by a positive gives you a negative quotient, so my answer here is negative 7. Let's simplify 36 divided by negative 12. 36 divided by 12 is 3, and a positive divided by a negative is a negative, so my answer is negative 3. All right, let's try another multiplication. 6 times negative 8. 6 times 8, that's 48. And a positive times a negative, that's negative, so my answer is negative 48. What about 0? How about 0 times maybe negative 3? Well, remember, 0 times any real number is 0, so 0 times negative 3 is also 0, and my product here is 0. If I have 0 divided by negative 2, well, 0 divided by any real number other than 0 will give you a quotient of 0. So for 0 divided by negative 2, my quotient is 0. And then don't forget, if 0 is in the denominator, for example, if I'm trying to simplify 5 over 0, that would be undefined. Okay, 5 over 0, that would be undefined. Okay? What about 2 times negative 3 times negative 4? Well, a positive times a negative, that's a negative, and then a negative times a negative will give you a positive, so the product will be positive, and then 2 times 3 is 6, 6 times 4 is 24. My answer would be positive 24 or 24. Let's try one more example, and then we'll go on to a review of operations on fractions. Let's simplify this. 4 times negative 1 plus 2 times negative 4 all over negative 1 minus 1. Let's begin simplifying. I'll start with the numerator. 4 times negative 1, that would be negative 4, plus 2 times negative 4, that would be negative 8, over negative 1 minus 1. Well, we're subtracting, unlike signs, but remember, for subtracting, subtraction is the same as adding the opposite. So this would be negative 1, and I'm going to add the opposite of 1, or positive 1. Its opposite is negative 1. I simply turned this subtraction problem into an addition problem. All right, let's continue simplifying. In the numerator, I'm adding two numbers with like signs. So add their absolute values. 4 and 8 would be 12. Keep that negative sign, the numerator simplifies to negative 12 over, in the denominator, I'm adding two numbers with like signs. Add the absolute values. 1 plus 1 is 2, and keep that same negative sign. In this case, the answer to the denominator is negative 2. Then I have a negative 12 divided by a negative 2, which would be positive 6 or 6. All right, that's a review of operations on sign numbers. Let's now review operations on fractions. Remember, if you're multiplying two fractions together, you may cancel. I have 5 6 times 8 fifteenths. Notice the 5 and 15 have a common factor of 5. 5 divided by 5 is 1. 15 divided by 5, that's 3. And also notice 8 and 6 have a common factor of 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. Then I simply multiply the numerators together. 1 times 4 is 4 over 3 times 3, which would be 9. My product then is 4/9. Let's try a division problem. What about 20 over 3 divided by 6 over 5? Remember, when dividing, that's the same as multiplying by the reciprocal of the divisor. So I'll turn this into a multiplication problem. This would be 20 over 3 times the reciprocal of 6/5, which would be 5/6. And please don't forget, you may not cancel until the operation is multiplication. Now that this is a multiplication problem, we can look for any possible canceling. 6 and 20, there's a common factor of 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. That's all the canceling I can see. So numerator times numerator, 10 times 5, that's 50 over 3 times 3, which is 9. My quotient is an improper fraction, but it is reduced to lowest terms, 50 then over 9. Okay, and by the way, if you want to turn it into a mixed number, I like leaving mine as an improper fraction, but you say 9 will go into 50 how many times? Well, it'll go 5 times, because 9 times 5 is 45, with a remainder of 5. So that's equivalent to 5 and 5/9. So that's multiplication and division. Let's look at addition and subtraction. For example, 3/4 minus 1/6. Remember, when subtracting two